Hello everyone, welcome back to my YouTube channel. In this video, we shall discuss a question on change in internal energy. So let's get started. Determine the temperature of system given that at 180 m, 4 moles of nitrogen gas react with 12 mole of hydrogen gas to form ammonia with a measured change in internal energy delta U of negative 400 kJ. The enthalpy change of the reaction delta H is given as negative 105.3 kJ per mole of nitrogen gas reacted. Alright, so the first step that we need to do is we need to write a balance equation for this reaction. So the reaction consists of nitrogen gas. It will react with hydrogen gas to produce NH3. So this one you need to balance out the equation first since you have 3 hydrogen here. So the best thing that we can do is here you times 3 and then here you times 2. So 2 times 1 is 2, so you do have 2 nitrogen here and 6 hydrogen on both sides. Alright, so when we look again at the question, it states here that the enthalpy change of the reaction, delta H, is given as negative 105.3 kJ per mole. Therefore, we can say that delta H is equivalent to negative 105.3 kJ. Right, this is only for 1 mole. But in the question, it states here that 4 mole of nitrogen gas is reacted with 12 mole. So what we are going to do is we are going to fix this equation here. So this one we need to times 4. So 4 and 2 plus 4 times 3, 12 hydrogen. So this one will produce 8 NH3. So it's the same, 4 mole of nitrogen react with 12 mole of hydrogen. So 4 mole of nitrogen react with 12 mole of hydrogen. So your delta H should be equivalent to negative 105.3 times 4. So you should get negative 4.2120 times 10 to the power of 2 kilojoule. So this is the first step that you need to do. Alright, so let's look back at the question. You were given change in internal energy. So the change in internal energy, which is delta U. So we can use the formula for delta U. So delta U is equivalent to delta H minus RT delta N. So basically you know what is delta U already. Delta H is the one that we just calculated. R is a constant value. T is what you want to calculate, and now we need to find what is delta N. So we are going to refer back to the balance equation that we have done for N2, whereby N2 is gas, plus 12H2, and H2 is gas as well, to form 8NH3, which is a gas as well. So your delta N should be equivalent to whatever in the product, which is 8, minus the summation of whatever in the reactant. So 4 plus 12. So 8 minus 16. So you should get negative 8. So this is the value for your delta N. Alright, so now we just have to plug in all the value inside the formula. So delta U is negative 400 kilojoule. Delta H is negative 4.2120 times 10 to the power of 2 kilojoule minus R. So your R should be 0.008 314, and the unit should be kilojoule per mole Kelvin. And your T is the one that you want to calculate, and your N should be equivalent to -8. Alright, so from here you can find the value of T should be equivalent to, so I'm just going to calculate this part first. So it's going to be 2.1200 times 10 to the power of 1 kilojoule divided by 6.6512 times 10 to the power of -2. Therefore, your T should be equivalent to 318.74 Kelvin. So let's look at the unit. So basically here you have kilojoule and you bring this part here. So this one you can slash out, and then this one as well. And the mole is here, 8 mole. So you can slash this out. Therefore, you will be left with just Kelvin for the temperature. So this is the final answer for this question. Thank you very much for watching this video from the beginning to the end. So I'll see you again in the next video. Goodbye.